Consumption from Kafka suddenly stopped. Messages from Kafka are being lost or are being dropped by my Dataflow pipeline. Most Dataflow workers are showing very little CPU utilization. These are some of the common complaints that I've heard from customers who are trying to build a reliable Dataflow pipeline which consumes from a Kafka source. I am Supriya, and I'm a technical solutions specialist from Google Cloud. I specialize in troubleshooting production-critical issues for Google's top 50 customers with a focus on data products like Dataflow, PubSub, and Dataproc. Today, I will be talking to you about ways to optimize parallelism for reading from Apache Kafka to Dataflow. This is the agenda I have planned for you today. I'm going to be walking you through the fundamentals of Kafka, of Dataflow. I'm going to be presenting to you the challenge of parallelism, some of the common symptoms that customers see when their Dataflow job isn't doing so well, and what mitigations do they attempt at that time, why those work, why those don't work, and of course, we'll be discussing the recommended ways to unlock parallelism. Kafka, as we know, is a distributed publish-subscribe messaging system. A Kafka cluster durably organizes incoming data on servers called brokers. This data is categorized as topics. A topic is the most fundamental unit of organization in Kafka. It is characterized by partitions for parallel processing and replication for fault tolerance. A consumer group is a set of consumers that work together to read and process data from the Kafka topic. At any given time, each partition is being consumed by exactly one consumer within the consumer group. The consumer uses a marker called consumer offset to track its position in the topic. As the consumer advances, the consumer offset is committed. Coming to parallelism in Kafka, the foundational unit is a topic partition. So generally speaking, more the number of partitions, higher is the parallelism. For example, if a topic has 30 partitions, then an application can run up to 30 instances of itself to process the topic's data, with each consumer reading from one partition at a time sequentially. If there are more than 30 instances, then in the context of reading from Kafka, they'll remain idle. Before we dive into the challenge of optimizing parallel consumption from Kafka, let's establish the consumer of choice, Dataflow, and some of its fundamentals. As many of you already know, Dataflow is Google Cloud's fully managed service for executing streaming and batch pipelines, which are built with the Apache Beam SDK. So you write the code, and Dataflow handles most of the rest, like scaling, exactly once processing, seamless integration with other GCP products like PubSub, BigQuery, reliable monitoring, and logging. This is what a Dataflow pipeline normally looks like. There's a source, there's a sink or a destination. You use I/O connectors to talk to different sources and sinks, and in between, you can have as many transforms as you want to process the data in any way that you want. For this discussion, the source is a Kafka topic, and the consumer of choice is Dataflow. Now let's look at how we will work in the I/O connector. So the I/O connector is Kafka I/O, and you can call it either using the managed I/O or directly. Yesterday, there was a great session covering what managed I/O is, how it works, what are its benefits. So please be sure to check out the recording if you missed that. But to give you a brief introduction of what it is, managed I/O offers a single configuration API to set up different I/O connectors, which makes your pipeline code simpler and consistent to read. It allows Dataflow a way to automatically manage connector upgrades without needing to modify the code and without you needing to upgrade the SDK version that's being used. Kafka I/O, you call Apache Beam's native flexible connector directly, and users can tune parameters related to consumer group configuration, offset management, polling behavior, and a few other things. As I was saying earlier, these are some of the common pitfalls that customers face while reading from Kafka via a Dataflow pipeline. And some of the mitigations that customers usually try in these situations is restarting the Dataflow job, adding more resources, adding more partitions to the Kafka topic. These may not always work. What can we do instead? The best way forward is usually to look at what the Dataflow job is telling you and then choose the best course of action. This is what a Dataflow jobs console looks like. Each little point that I've highlighted here is very useful to understand how the job is doing. Let's look at the job graph itself. Each box here represents a step or a transform in the pipeline. Clicking on the box exposes this little step info panel to the side. And you can look at the input and the output metrics. You can look at things like elements added, and you can compare either the input or the output metrics with each other, or you can compare subsequent steps to understand how the step itself is performing. It's important to note that while reading from Kafka, Dataflow assigns one thread to each Kafka partition. I'll talk more on this later. This is the execution details tab. The steps we saw in the previous job graph have been fused by Dataflow into 3 stages: F19, F20, and F21. This stage progress view will indicate if there are any stragglers that are falling behind that you need to look at. Yeah, changing the graph view to stage workflow, and clicking on each little box will tell you what are the component steps that have been fused together. This is especially useful when we are trying to troubleshoot and look at the Dataflow metrics, which I will show you next. When solving a customer issue, these are some of the common metrics that we generally rely on. The first one here is data freshness. This tells us the difference between when a data event occurred and when it was processed by Dataflow. Next, we have system latency. This tells me how long a record is waiting to be processed by a particular step. If the values for data freshness and system latency are growing, or they're high, then it tells us that some operation along the way has gotten stuck, and we need to look into what happened. Similarly, to help us with that, we have 2 metrics, backlog seconds and backlog bytes, which are useful to identify where the records are waiting to be processed. This backlog value is an estimation by Dataflow. As you can see in this image, the backlog for stage 20 is growing towards the very end. I think the backlog is about 20 MB, and what Dataflow is estimating is that it can consume this backlog in 3 to 4 seconds. This is especially where it's useful to understand what are the component steps so that you can dive further in and troubleshoot. Next, I want to show you this parallelism metric. It tells you how many keys are being used per stage. Is a particular stage showing too few or too many keys? Based on this information, what are some of the changes that you can make to unlock optimal parallelism? We'll discuss more on this next. The last 2 metrics that I want to draw your attention to are CPU utilization and memory utilization. They tell us how the workers' resources are being used. Are they reaching the limit? Is there a lot of skew? How is the resource usage? Coming back to the job console itself, notice these little tabs under logs at the bottom. Looking at the logs here can be quite indicative. The diagnostics tab especially is very useful, and it supplies you with immediate information on what warnings or errors are being logged by your job so that you can focus right there. Clicking on that little arrow that points outward will take you to Logs Explorer, and that comes with a preset filter query for you to use. And there you can look at things like startup logs, job messages, and the ones that we rely on mostly, the worker logs. Based on my experience troubleshooting issues related to unlocking Kafka's parallelism while reading from Dataflow, there are 3 broad categories where we can make some changes to try and tune this. The first and foremost point of choking is often the number of partitions at the Kafka source topic. A good rule of thumb is to have partitions equal to twice the number of vCPUs that are available. For example, if your Dataflow job is set to use N1 standard 4 machines for the worker nodes with an upper limit of 10 workers for auto-scaling, then the number of partitions should ideally be 2 times 4 times 10, which comes to 80. Another useful formula to note is this one. Dataflow defaults parallelism to 4 times max number of workers. max number of workers, again, is the upper limit of autoscaling that you have configured. So it's a good idea to have at least 4 times 10, which is 40 partitions. So if this is what you're testing with, N1 standard 4 machines with 10 max number workers, then it's a good idea to start testing between 40 to 80 partitions in your Kafka source topic. Next most noteworthy tuning point is to inspect the partitions themselves. As I will discuss next, there are ways to expand the key space for improving data flow's parallel processing. But if the incoming partitions themselves are skewed in terms of the data volume, then every step of the pipeline is tied to that choke point. This is when we most often see a noticeable difference in the CPU utilization, as you can see in the graph there. Workers that read from particularly lighter load partitions are going to have a little to no CPU usage, whereas the ones that are reading from hot partitions are going to maybe fall behind or are going to show much higher CPU usage than the others. Dataflow, with the help of dynamic work rebalancing, Dataflow will try to assign multiple low-volume partitions to one worker. But what it may not be able to do is break up a hot partition and assign that to multiple workers. So it's important for users to examine the Kafka producers and their key space and balance the incoming load equally among the partitions. Let's look at the next category. What changes can be made at the Dataflow level? The first suggestion comes from the most commonly faced issue of the read from Kafka step not being able to keep up with the incoming load. It has fallen behind or it has stopped reading. Adding a redistribute will help in 2 ways. First, it expands the key space by adding a shuffle step. Recall that each Kafka partition is read by one thread of a Dataflow worker. Instead of being bound to the same thread by which the records were read, records can be shuffled and distributed across more threads. For example, if there are 10 partitions and 100 workers, only 10 active threads are reading from Kafka at a given time. Adding a shuffle after read from Kafka can take the records from these 10 threads and redistribute them to 50 or even 100 threads. The second benefit of adding a shuffle step like this is that it unfuses read from Kafka from subsequent process-heavy transforms. Dataflow might fuse the read from Kafka step with subsequent steps and assign this fused step to a single thread, which will cause the entire pipeline to slow down and for other threads, think workers, to be idle. Adding a shuffle step tells Dataflow not to fuse these 2 steps, allowing threads to parallelly work on reading and then processing the records. This step is especially useful when, for some reason, the number of partitions at Kafka cannot be modified to achieve optimal parallelism. So far, we focused on expanding the key space and increasing the number of active threads. However, occasionally, the other extreme has also happened where the number of keys was too high, it was almost unlimited. With too many keys, the work bundles that Dataflow creates for processing are very small, which means slower processing and generally a backlog buildup. As you can see here, this was one example where this stage F78 had close to 7 million keys. It's generally a good idea to start testing with 10K to 20K keys. And how can the number of keys be controlled? Using Kafka IO read with redistribute num keys and passing the integer keys. Next, let's look at the resources available to perform the required work. Users can look, of course, at the CPU usage and the memory usage metrics that I showed you previously. Another good place to look into is the recommendation in the auto-scaling tabs in the Dataflow job console itself, which tells you if there are any quick things you can change, some hints to improve resource utilization. The final category is Kafka IO. Let's now look at some parameters in the consumer configuration which users can play around with to reach optimal parallelism. The first 2 parameters, unbounded reader max elements and unbounded reader max read time milliseconds, determine the bundle size. In Dataflow, records are processed in bundles. Increasing the values for these 2 parameters will create larger bundles. This is better for performance, but may slightly increase latency. These values can be set in the Dataflow pipeline options. The default values are 10,000 and 10 seconds each. Users can begin with a much larger value, say 100,000, and modify it based on how the job is doing. Similarly, we have max poll records, fetch max bytes, and max partition fetch bytes. Increasing the values for these parameters will allow more messages to be fetched from Kafka to Dataflow, and thereby reducing the number of requests that have to be made. In turn, improving the performance, but again, may slightly increase the latency of the read from Kafka step. The default values of 500, 1 MB, and 1 MB respectively can be set by calling with consumer config updates. Especially with the use of runner v2, customers or users can test with 100 MB instead of the default 1 MB and 10,000 or more rather than the default 500. The last parameter that I want to highlight is the consumer polling timeout. Let's say you're noticing timeout exceptions in the jobs logs. This would be a good time to consider increasing the polling timeout, which takes care of any delay in the reads, possibly due to a slowness in the network. The default is 2 seconds. It can be increased to a more tolerant value, depending on how the job is doing, by calling with consumer polling timeout. So to review 3 points, three places where you can make a few changes to unlock optimal parallelism while reading from Kafka through your Dataflow pipeline. The first is at the Kafka partitions. General rule of thumb, more the partitions, higher the parallelism. These are two formulas that you can rely on to begin testing and load testing and troubleshooting. The second place is at Dataflow, where you can add a redistribute step after read from Kafka. This will help in 2 ways. One, it will expand the key space. Second, it will separate read from Kafka from subsequent steps, causing more active threads. And of course, look at the resource usage. Choose the right worker machine and the right count for the number of workers. The last place is at Kafka IO itself. Increase the number of bundles that Dataflow is going to use, increase the amount of data that's going to be pulled, reduce the number of requests, and increase polling timeout to smooth out any delay in the network. This is everything I wanted to show you today.